Hey class, welcome everyone to today's session. And today we are doing under Umang series for your grade 9, and we will be discussing about number system chapter 1, and we'll be discussing about rational and irrational numbers. So as you all know that we have put a poll in the Vedantu 9th and 10th community page, and there I have got the maximum response from this topic, rational and irrational numbers, and other two topics as well. So those also we are going to cover as well. Got it? So today's topic will be all about the introduction to your rational and irrational numbers. Got it? So to understand the rational and irrational numbers, if you remember in your grade 8, you have learned about the rational number, and there you have learned the definition that rational numbers are written in the form of p by q, where p and q are integers and q is not equal to 0. Right? We have learned this about rational numbers. Okay, about rational numbers, we have learned that it can be written in the form of p by q, where the condition is what? P and q are integers, first condition, and second is q should not be equal to 0. Correct? These are your two conditions, right? So that was the fractional form. So when you look at the fractional form, how can you say that a number is a rational number or not? Got it. So for example, 3 by 4, minus 5 by 3, 1, 2, all these numbers comes under the category of rational number. Now we are going to look at this part, that is your rational and irrational numbers, by looking at their decimal forms. By looking at their decimal forms. How do rational numbers or irrational numbers looks like in decimal form? And you know irrational numbers are like root 2, root 3, root 5, any number inside the square root which is not a perfect square, right? So that form you have learned, but today we are going to learn this part, that is what is rational, what is irrational, based on how their decimal expansion will look like. Got it? So that is the major part which we are going to study today. So let us understand what I'm going to tell you. So let us look at different types of decimal form, different type of decimal numbers. For example, let's say if I talk to you about the decimal expansion of 1 by 2. 1 by 2's decimal expansion is 0.5. If I talk about 1 by 5, its decimal expansion is 0.2. If I talk about 1 by 10, its decimal expansion is 0.1. Right? So as you can see that after the decimal, the number of digits after decimal, they are the finite digit. For example, 1 by 4 is 0.25. 1 by 8 is equal to 0.125. So everywhere you can count the number of digits after decimal. Suppose 1 by 2 after decimal there is only one digit, that is 5. In 1 by 8 there are three digits after decimal, that is 125, 0.125. Correct? So here as you can see, finite digits after decimal point, finite digits after decimal points. So this is one kind of decimal number. So the name for this part, as you can see, the number of digits after decimal expansion, you can count them. When you will divide 1 by 8, if you will divide 1 by 8, so let us divide 1 with 8, so you cannot divide it, put a decimal and you can put a 0 here. 8 ones are 8, subtract it, remainder 2. Then you can say you can put a 0 because decimal is already there. 8 twos are 16. Okay, subtract it, remainder 4, and you can say 8 fives are 40. Correct? So you will see the decimal gets over, the division gets over, you get a remainder 0 at the end. So these kind of numbers are called what? The decimal which have a finite number of digits after decimal. So this is the first category of the decimal number which we are going to talk today, and these decimals are called terminating decimal. These decimals are called what? They are called terminating decimals. So make sure you understand this part. Terminating decimal means the number of digits after decimal are finite. You can count the number of digits after decimal. That means if you will divide it at one place, the decimal will get over. Got it? So this is the first category. Now let's come to the second category. The second category, if I talk to you, then let us take the example of Let's say second category we are talking right now. So let us take the example of, let's say, 1 by 3. 1 by 3 is decimal expansion if we will look. So let us divide 1 with 3. As you know, we cannot divide it, so put a decimal. Here put a 0, so you can see 3 3s are 9. Subtract it, remainder 1. Okay. Again you can put a 0, that is again the same step. Again 3 3s are 9, and I can see again remainder is 1, right? Again I will put here 0, I will put here 3, I will put 9, 3 3s are 9, subtract it, again remainder is 1. So this process will go on and on and on, and here also this 3 will keep going, keep going, keep going. This will never end. This decimal, no matter how long you keep going it, you utilize the every page or every paper present in the world, the decimal will never get over. You will never get remainder 0. The division will never be complete, or every time, every step, your remainder will be 1. Correct? So this is the second type of decimal in which you can see that the decimal is not ending. So 1 by 3 is supposed as 0.33333 and so on. 1 by 9 is suppose will be 0.11111 and so on. So these are the second type of category in which you will see that the number of digits after decimal, the number of digits after decimal are never ending. That means you cannot count how many digits are present after decimal. There are infinite digits after decimal. There are infinite digits after decimal. Got it? So first thing is infinite digits after decimal. That means the division will never get over. The division will never get over. What is second thing which we learned about it? The second thing you will see that there is a pattern over here. There is a pattern over here. This 3 is repeating itself again and again and again and again and again. In 1 by 9, 0.111111 is repeating itself. So there is a particular repetition. There is a particular repetition. So this is your second category in which you will see there is a repeated pattern. There is a repeated pattern. Got it? There is a repeated pattern. So this is your second case lies in which there is always a repeated pattern. And in this part, this repeated pattern, watch what you are getting here right now. First thing, infinite digits after decimal, and the second thing that the decimal, the division will never be complete. So these are the two unique things about these second kind, about the second kind of decimal expansion, and this is called as your non-terminating. First thing, why non-terminating? Because the division never gets over. Because the division never gets over. So it is non-terminating and recurring. What do you mean by recurring? Recurring means that there is a pattern. Recurring tells you that there will be a pattern. Now, if I give you some other examples, for example, let us say 0.232323 and so on, 0.123 and so on. So the pattern can be of 1 number, 2 number, 3 number, 4 number, 7 number, 9 number, 11 number, whatever it is. It can be anything, but there must be a pattern, and the division should never get over. So this dot 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 at the end says that the digits are continuing itself in the same order. Got it? So this is your second category, which comes as non-terminating and recurring. Then there is a third category. Then there is a third category. What is that third category? Understand here. The third category, if you will see, suppose you have learned in your grade 8 the long division method, right? In which you have learned that root 2 is equal to 1.414 something 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 something. Square root of 3 is equal to 1.732 something 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 something. And I can also write a decimal digit in which there will be no pattern, and the digits will go on and on and on. So for example, if I write suppose one thing something as 1.0100100020003 anything, there is no pattern at all. There is no pattern at all. So here you will see that although this case is also of non-terminating, but there is no pattern. So what are the two important things which we have learned? First thing, Infinite digits after decimal. First thing, infinite digits after decimal. Okay, and the second case that we have got here is that no repetition or no pattern at all. No pattern. There is no pattern. There is no pattern. Nothing is repeating itself again and again. There is no repetition here. Instead of pattern, I will say no repetition. Okay, we want repetition. So there is no repetition. Got it? So the main thing is what? Here we don't have any repetition. No repetition. Got it? So this is the third category. So the name of this third category is called non-terminating. Why non-terminating? Because we know there will be infinite digits after the decimal. There will be infinite digits after the decimal, and since there is no pattern, so they are called non-terminating and non-recurring decimals. Non-terminating and non-recurring decimals. Got it? So these are your three different types of decimals. These are your three different types of decimals. So we are not talking about right now what is rational, what is irrational. I have just told you what are the different types of decimal numbers are there. So there are three different types of decimal number. One is called your terminating decimal. One is called your terminating decimal, and the main thing over here is that there will be finite digits after decimal. That means you can count the digits, the division will get over. If you will keep dividing it at one place, definitely you are going to get your remainder as 0. Got it? Then comes the second category, that is your non-terminating and recurring. So non-terminating, that means there will be infinite digits after decimal, and recurring means there must be a pattern. There will be a pattern. So that means I can say, okay, 3 is repeating itself, 1 is repeating itself. There must be a repetition. In 0.2323, you can say 23 is repeating itself. 0.123, is repeating itself. So there is a repetition. And then comes the third category, that is your non-terminating and non-recurring, in which there will be infinite digits after decimal. That means the number of digits after decimal will never get over. There will be digits, and there will be no repetition at all. You cannot say that this thing is repeating itself again and again. There will be random numbers without any repetition order. So that is your third category, that is non-terminating and non-recurring. So now out of these three, which one is rational, which one is irrational? Let us discuss that part. Let us discuss that part. Okay, so I will talk about the decimal numbers. We will talk about the decimal numbers. So I have told you already that the decimal numbers, okay, first category is your terminating decimal. First category is your terminating decimal, and the second category is your non-terminating. Non-terminating. And then this non-terminating category again further is of two types. One is repeating or recurring. There must be a pattern. And the second is your non-recurring. Second is your non-recurring. Got it? So one is terminating, non-terminating and recurring, non-terminating, non-recurring. Correct? So out of these all, you will be shocked, you will be get to know that these terminating and the non-terminating and recurring, these two are coming under rational number. These two are rational number. That means if a decimal number is terminating, or even if it is non-terminating, but if there is some repetition over is there, that means there is some pattern over there, then that will be an example of the rational number. So earlier we have learned about the p by q form, fractional form. Now we are learning about the decimal form. Both the definitions are correct. See, 1 by 2 is 0.5, rational number. 1 by 3 is a rational number, and the decimal expansion of 1 by 3 is 0.33333, and so on, which is again a rational number. So there is no contradiction. Okay, we are saying the same thing. So terminating and non-terminating and recurring comes under the category of rational number. And the third category, which you have here, which is non-terminating and non-recurring. Sorry, which is your non-terminating and non-recurring. Okay, this category This category comes under irrational number. This category comes under irrational number. Got it? So this is as simple as that. So if I give you an example of rational numbers, if I want to give you the example of rational numbers, so the examples of rational numbers for us will be, suppose, square root of 2, square root of 3. Okay, then you can say square root of 5. The number should not be there. So all the numbers which are inside square root and they do not have they which are not a perfect square will be, oh, I'm sorry, I have written it wrong here. This part I have written it wrong. It should be written over that side. It should be written over that side. Okay, so what I was saying, that rational number, so rational numbers category will be what? Very easy, by whatever you have learned. If you want to talk about the fractional form, so 1 by 2 minus 3 by 2, okay, 4 by 5, all these are rational numbers. And if you talk about the decimal pack category, so 0.5, 0.3, okay, 4.52, anything which is terminating, or for example 1.32, 32, 32, and so on. So these all are coming under your category of rational numbers. And if I talk about the category of irrational numbers, if I talk about the category of irrational numbers, then under irrational numbers we will be getting square root of 2, square root of 3, square root of 5, remainder square. Remember, square root of 4 will not be irrational because square root of 4 is 2. Okay, then in the decimal form, if you want to write, because see, remember, square root of 4 is 1.414 something, there is no pattern at all. Okay, you will use that long division method, and you can check using long division method as well. No matter how long the division will be, there will be no pattern at all. Then other categories is, suppose, 1.2342952 and so on. So there is no pattern at all. There is no pattern at all. Okay, or 1.0100100001 and so on. So there is no pattern. You cannot say that this 01 is repeating itself. No number is repeating itself again and again. No unit is repeating itself again and again. Got it? So these are your examples of rational and irrational number. Terminating and non-terminating and recurring are your rational number. Non-terminating and non-recurring are your irrational numbers. Okay? So let us understand this concept further with the help of some examples. So some questions we'll be looking at. First question: between two rational numbers, there is no rational number, there is exactly one rational number, there are infinitely many rational numbers, there are only rational numbers, and no irrational numbers. So let us take an example. I have, suppose, 1 and 2. 1 and 2 are my two rational numbers, right? Now I can write between them, infinite rational numbers I can write, because I can write 1 as, suppose, 100 by 100, 2 I can write as 200 by 100. है ना? Let us write 1 as 1 by 1, multiply and divide both with 100. So right now I can see between them how many numbers are there. So between them the numbers are 101 upon 100, 102 upon 100 till 199 upon 100. You got it? So there are these many numbers in between them. Now, so you can say, sir, I've counted, na? There are only 99 numbers. So why we are saying there are infinite numbers? Because this one, instead of writing it as 100 and 100, I can write it as big as I want. I can write it as big as I want. Correct? This 2 can be written like this. So now you can see this pattern will go on and on. Again, multiply with 10, multiply with 10. So there again will be infinite numbers. Correct? Now, so I can say there are no rational numbers. This option is wrong. There is exactly one rational number. This is also wrong. Now look at option D. Option D is saying there are only rational numbers and no irrational numbers. And I strictly don't follow this, because between 1 and 1, 1 and 2, I can write as 1.01, 2, 0, 1, 3, 2, 4, 5, 2, and so on. So you can see this is an irrational number and it is 1 point something. So it is greater than 1 and it is less than 2. So between them there are irrational numbers, and this way I can write infinite rational numbers. I can write infinite rational numbers. So option D is also wrong. Option C is your correct answer. So the more appropriate way of writing it is, between two rational number there lies infinite rational and irrational numbers. Okay, there are infinite rational number as well as infinite irrational number. No matter how small numbers you will choose, how close to each other number you will choose, still between them you can write infinite numbers. Okay, you can never write the smallest number. You can never write the number which is closest to zero. These numbers that will go near to zero, there always you can reach more and more and more closer to zero. So there is always the answer, between two rational number there lies infinite rational numbers and as well as infinite irrational numbers as well. Got it? So option C is your correct answer. Let's go for the next question. Next question is this: decimal representation of a rational number cannot be. So I already know that for a rational number, the decimal representation will be either terminating or non-terminating and recurring, correct? So option A, terminating, no. Terminating can be rational. Option B, non-terminating. Ab beta dekho, in non-terminating you have to specify whether it is recurring or non-recurring. Correct. So non-terminating is both type. It is recurring as well as and as well as non-recurring also. So only saying non-terminating is not sufficient. So option B is also not correct. Correct? Because non-terminating numbers, in non-terminating you are including non-terminating and recurring as well. So B is not correct. C is correct. C is not correct because non-terminating and repeating numbers, yes, they are also rational. So we know A and C are rational. B can be rational. If I talk about non-terminating and recurring, then rational. If I talk about non-terminating, non-recurring, then irrational. So B may be correct, may not be correct. B is not the sufficient sentence. But D is your correct answer. A rational number cannot be non-terminating and non-recurring or non-repeating. Correct? Because non-terminating and non-repeating numbers are your irrational numbers. I'm telling you, beta, the decimal way, in the decimal form, the rational, distinguishing between the rational numbers and the irrational numbers is very easy. So option D will be your correct answer. Let's go for your next question. The product of any two irrational numbers. Now understand this part. Product of any two irrational numbers. So if I multiply square root of 2 with square root of 3, you know the answer will be square root of 6. So irrational number when multiplied with irrational number, you got your answer as irrational number. If I multiply square root of 2 with square root of 2, I am getting my answer as 2. So here you can see irrational number multiplied with irrational number is giving you a rational number. Okay, is giving you a rational number. I am not, don't think that I am using I as to represent irrational number. I'm just using the short form for irrational number. Okay, just using the short form for irrational number. So you have seen with the example that irrational number into irrational number can be irrational as well as rational. Got it? So the correct answer will be sometimes rational, sometimes irrational. It can be anything. So option D is your correct answer. Let's go for the next question. Which of the following is irrational? Which of the following is irrational? And now you can see they have given it to you in the square root form. They have given this to you in the square root form. So we will see that inside the square root, if there is any perfect square, then it can come outside of that square root and that will be a rational number, correct? So that same method we are going to apply here. As you can see, it is square root of 4 upon square root of 4 by 9. So it can be written as square root of 4 upon square root of 9. Remember, the distribution of this square root sign you can only do in division or in multiplication. That means square root of a into square root of b, then you can take square root of common, you can write it as a into b. Or if square root of a divided by square root of b is there, then you can do square root of a divided by b. Only in division and multiplication this is possible. if i write if I write the same thing, if I write this same thing in suppose addition or division, that means if I write it like square root of a plus square root of b I'm writing as square root of a plus b. So my dear friends, this is a sin. This is a sin of mathematics. Please don't commit that sin. It is absolutely wrong. So you cannot take the square root common in case of addition or subtraction. Only in multiplication or division you can do that. Only in multiplication or division you can do that. Okay. So now let's understand this part. So beta, first option, in the first option, you can see now that square root of 4 will be equal to 2 and square root of 9 will be equal to 3. As simple as that. Here square root of 12 by 3. So I can say that it is 3 ones are 3 fours are. So you are left with square root of 4 which is equal to 2, which is again rational. Option D, square root of 81 is nothing but 9 because 9 square is 81. Correct? And option C, here you will see inside the square root we have a non-perfect square. It is not a perfect square. 7 is not a perfect square. So option 7, option C, that is square root of 7, will be your irrational number. So you should be able to identify the irrational number as well as rational number both in the fractional form as well as your decimal form. In the fractional form, if it is something integer upon some integer upon integer is there, then it is irrational. If sorry, then it is rational. If it can be converted, p by q form can be converted in the form like integer upon integer, then rational. But if there is something square root or something like that, then it will be irrational. As simple as that. Got it? Now let's move to the next part. So option D is your correct answer. The next question beta we have is which of the following is irrational? Which of the following is irrational? So I know if I'm talking about irrational numbers, then it will be non-terminating and non-recurring. What it will be? Non-terminating and non-recurring. Correct? So here, as you can see, option A is your terminating decimal. I hope all of you are sending the answer in the chat box. Okay, because I want all of you to perform this as your quiz and please post your answer in the chat box beta. So as you can see, the first one is 0.14, which is terminating decimal. In the second one, acha, what is the meaning of this bar? Suppose if I have 1.33333 so on. So instead of writing it as this big number, I can write it as 1.3 bar. So the number on which bar is given, that means that number is repeating itself again and again and again. For example, if I have 0.25, 25, 25 and so on. So here you can see 25 is repeating itself. So I can write it as 0.25 bar. Okay. Suppose if I have 0.125555 and so on. So here you will see only 5 is repeating itself. 1 and 2 are not repeating. So you will be writing it as 0.12 and the bar will be only on 5. The bar will be only on 5. Got it? So this way, I can say this number is nothing but 0.1416161616 and so on. So 16 is repeating itself. So you can say it is non-terminating and recurring, which means it is rational. Option C, again it will be 0.1416, 1416, 1416 and so on. Sorry. So you can clearly see option B and option C are very different. Here only 16 is repeating. Here the whole 1416 everything is repeating. So the bar decides the number. Bar is very important part there. Okay. So whole 1416 is repeating, but I know it is again non-terminating and recurring. So option A, B and C are either terminating or non-terminating and recurring. That means they will be rational. But in option D, you will see that I cannot place bar anywhere because that same digit will never repeat. 401 400 140, there is no pattern at all. Nothing is repeating itself again and again. So option D is an example of non-terminating and non-recurring number. So I can say option D will be your correct answer. Option D will be your correct answer. Correct? Let's move to the next question. Next question is this: a rational number between square root of 2 and square root of 3 is, which one of these is a rational number between square root of 2 and square root of 3? So first understand this thing beta, they are asking about the rational number. So those of you who are giving me answer right now, okay, out of you, those who are giving me option A or B as their answer. So for your kind information, I would like to tell you both that these option A and B both are irrational numbers. Both are irrational numbers, and I know a irrational number. The question is asking me rational number. So A and B cannot be the answer. That is how you have to think. The question is asking about rational number. A and B cannot be that. Correct? Now we have to find out a rational number between square root of 2 and square root of 3. So we know that square root of 2 is 1.414 and so on. If you don't know the decimal values, at least write, remember it for square root of 2 and square root of 3. If you don't understand it, use the long division method for finding out square root, which you have learned in your grade 8 in the topic square and square roots. Got it? And square root of 3 is 1.732 so on. So I can say if I want to write a number between square root of 2 and square root of 3, it should be greater than 1.4 something and it should be less than 1.7 something. So between them, I can write many numbers. Now 1.5 is there, 1.6 is there, 1.5 to 1.55, like infinite numbers are there. Now you can see 1.8 is greater than 1.732 and so on. That is, it is greater than square root of 3. So 1.8 will also not be correct answer. Option C is correct answer. That is, I can say 1.5 is a number between square root of 2 and square root of 3, and it is a rational number. It is a rational number. Got it? Let's go for the next question. The next question is this. Find 5 rational numbers between 3 by 5 and 4 by 5. Now, whenever you have to find out the rational number between two given rational numbers, so suppose you have here 3 by 5 and here you have 4 by 5. So this you have already learned in your grade 8 that what you are going to do is you are going to multiply and divide both the numerator and denominator. Okay, you are going to multiply and divide both the numerator and denominator with a number large enough so that I can get some values. So for the easiest calculation, multiply with 10 or 100 or something like that. So if I multiply it with 10 here, both the numerator and denominator, and here also both the numerator and denominator, you know that the number will not change. It will form equivalent fractions. So this will become 30 upon 50 and this will become 40 upon 50. Correct? So between 30 upon 50 and 40 upon 50, you can see we have 31 by 50, 32 by 50, 33 by 50, up to 39 by 50. So there are 9 rational numbers. Out of these, write any 5 you want. Or out of these, write any 5 you want, which is the rational number in the fractional form. Suppose if they ask you irrational number also. Suppose if they ask you irrational number. So in that case, what you will do, I am talking about the irrational number as well. Okay, in this case, what I'm going to do is, let me just choose the pen here. Not able to select the pen. Okay. Hmm. Okay, so let's keep the ink this only. So 3 by 5, if you will write the decimal number, 3 by 5, if you will write it in the decimal form, divide 3 by 5, so you will get 0.6. And divide 4 by 5, you will get 0.8. So now we need to write the irrational number between 0.6 and 0.8. So you can start with, let us say, 0.61, 01, 0001, 0.103 something and so on. Correct? There is no pattern at all. You can write it as 0.6234252972342 something, go on, 4 5 and something, go on and on and on and on. Correct? So this way again you can see there is no pattern at all. 0.792345972, okay, 4 9 8 9 8 8 9 something and so on. So again, these are your will be your examples of irrational numbers. So whenever they are asking you to write irrational numbers, find out the decimal form of those two given numbers and then write between them the non-terminating and non-repeating irrational numbers. Got it? This is how you can get the rational number as well as your irrational numbers. Correct? Okay, so this was all. Now I have a homework for you. I have a homework for you. The homework for you, which I have, I want all of you to answer in the comment box. What is your homework? The homework is that beta, you know pi. First thing, pi is told to be an irrational number. Okay, pi is told that pi is a irrational number. Pi is what? Irrational number. But I know that when I solve the circumference or the area problem for the circles, I take pi as 22 by 7. And 22 by 7, if you will see, it is in the form of p by q, where p and q are integers, q is not equal to 0. So you are on one hand you are telling me pi is irrational and I know pi is 22 by 7 which is a rational number. So how I am saying that something irrational and something rational is equal? Am I making a mistake? Is pi rational? Or is pi irrational but 22 by 7 is irrational? No. 22 by 7 is definitely rational. P by q form, q is not equal to 0, p and q are integers. So 22 by 7 is definitely rational. And you are saying pi is irrational. So are we making any mistake? Is pi rational? And if pi is irrational, how is this possible that an irrational number is equal to a rational number? How is it making sense to you? I want you to explain this to me in your own words in the comment box. Just try to give me the gist. I will get to know what you are saying. Okay. The answer I'm telling you, if you are telling me even the in the minimum word possible, you can write it in one sentence. The answer can be written in the one sentence, but if you want to elaborate it, I would be more than happy. Just let me know. Those who have got the answer for this, let me know in the comment box. I will go through it. Okay, so this is your homework task for today's class. Now, this was all about the irrational and rational number today. We have learned that the decimal numbers are of three types. Okay, we have learned that the decimal numbers are of three types: terminating, number of decimal digits after the decimal are finite, the division will get over, so that is terminating decimal. Then comes non-terminating and recurring. The division will never get over, infinite digits after the decimal, but there will be a repetition, there will be a pattern. And then non-terminating and non-recurring, that means there will be no, the division will not be over, infinite digits after decimal, and there will be no pattern at all. So out of those three types, terminating and non-terminating and recurring comes under the category of rational numbers, and the non-recurring, non-terminating, this comes under the category of irrational numbers. Got it? Then we have solved the different questions solved on this, and this is your homework question. I would be waiting for your answers in the chat box. Okay, and sure. So this was all. Again, I would like to tell you, all my dear students, that if you are stuck at home amid this, what if all of you are stuck at home right now, so you can visit the link vdnt.in/ytlive. You will get free access to all the live classes and content of Vedantu. Free access. Just trust me and check out that link. Okay. Second thing is, there's a surprise coming for you all. In the 2 days, in the coming 2 days, there will be a big reveal from our Vedantu side in the Vedantu app. So I would like all of you to download the Vedantu app, because in 2 days there's a huge surprise waiting for you all in the coming 2 days. So I'm waiting for you all. Download the app and let's see what is the surprise in the coming 2 days. Okay. And then VSET, very important part for all of you, those who are want to take admission in the Vedantu, just attempt VSET, Vedantu Scholarship Admission Test. The main thing about this part is there is 10 plus crores of scholarship, free registration. There is not a single rupee you have to pay to give this exam. No registration fee at all. Second thing, the exam you can take the exam at the comfort of your home. You can take it from your home. No need to go to any examination center. Okay, so if you want to register for Vedantu scholarship admission test, that is VSET, you go to the link vdnt.in/ytvsat, ytvsat, vdnt.in/ytvsat. Till now, there are 19,950 students have attended the VSET and 32.31 crores of scholarship has been won. Like Siddharth from Bangalore won 100 percentage scholarship, Nitish from Jalandhar 190 percentage, Himanshu again 190 percentage. So different students are getting. Please don't get left behind here. Please go for the VSET test. You will get a scholarship over there, and there is no registration fee, nothing to go out, nowhere at the comfort of your home. Give that examination. Okay, so I hope all of you enjoyed today's class. I'll be back with some other topic. Whenever the polls are coming, please vote on the topics which are really important for you, where you want me to give the session, because those only topics I'm going to pick. So please vote wisely and then give me a topic. Okay, next class again I'm going to see you in some other class with a new topic of the same chapter. We are going to discuss a new topic. Okay, so please like this video if you have loved the content what I have done today. Share this video with your friends who are still not aware that Vedantu Umang series for grade 9th is also happening. Many students don't know about it, so please reach out to them, share it with your friends, share it with all your school friends, all your society friends. Tell them that okay, the series is going on, no need to waste time, all of them can come on this platform for free and learn everything. Okay, share this video with your friends, and please, if you have not done it yet, subscribe to this channel and don't forget to press that bell icon. Got it? So this is all from my side in today's class. Thank you so much to all of you, and I hope I will be getting to see many and many and many answers in the comment box. Okay, so I'll see you soon, beta, in the next class. Till then, bye bye. Yeah, bye bye.